in Princeton last Friday, and real high-level, razor-sharp intellects was all involved. And what was really interesting is that most people were really polite and really pleasant and really sweet, except for this one guy who just went total doom and gloom. And what was really interesting, he wasn't dismissed by any stretch of the imagination, because the doom and gloom is very, very real. But part of what it did is it reignited in me some of the passion. Do you believe it? I've been passionless lately, flat. Some of the reasons why we're doing this is not funny. This is the end game. And if we, the human race, don't figure something out in a hurry, all of us as fast as we possibly can, there's going to be some really ugly stuff coming up. And if you think some strange things are going on with politics in the United States of America, it's quite possible that you ain't seen nothing yet. So let me get rolling. We were talking regeneration ecology and how it ties in with our agriculture. Regeneration, what causes natural plant communities to regenerate, to reproduce, to spread, to occupy sites, to be constrained to certain sites? The more we learn about how natural systems propagate and spread and grow and change through time, that's knowledge that helps us to guide our management decisions on our piece of property, whether it be small or large. Now this, believe it or not, you've seen the slide a zillion times, obviously. This was all the same status. It was a brushy, overgrown field 20 years ago. We've seen this before. There's the place on the left and place on the right. This looked the same 22 years ago. This was an old field, brushy, overgrown with some trees getting established. It was the establishment phase of succession. It had been grassland for a while, no disturbance, trees get going. Well, through time, growth in height and mass occurs. This is predictable according to the species and their habits and their behaviors. And this requires specific requirements of space, light, nutrients, and moisture, and biology, soil biology as well as above ground biology. All of those things, space, light, nutrients, moisture, and biology, those are our control knobs that allow us to adjust things. And remember, since we're dealing with plants that have a length of time during the growing season that they actually grow and reproduce, then they have during the years that they grow and reproduce. It's a little bit slower adjustment than, for example, when I was able to call back in and get audio back on my phone here. Light is the same thing. We're playing with different light levels, a higher density with a closed canopy to create more shady conditions, or open it up, remove material, remove plants to get more light penetrating, like you've seen several different times with me adjusting a canopy to get more grass growing. Nutrients, we can adjust for nutrients. We can add nutrients and not just NPK. There's all kinds of host of minerals that we can add to the soil that will help or hinder. Some just like on my farm, for example, I've used calcium, just calcium carbonate, as a way to discourage poison ivy, because it's an indicator. It thrives in soil that's low in calcium, and so just add extra calcium on it, and it doesn't do well. Then moisture, of course, we can irrigate if we want. We can dry things off if we want. Very significant with that is our earthworks to change the water pattern on the landscape, to collect water where we want to collect it, and spread it away from where we want to spread it to. Those are all our control knobs. Then the reason why I said that these requirements may not be sufficient for some species selection is very important. Why would you want to start with some species that have no history or track record of where you're growing, or where you live? Why would you pick species that have no track record of living in a natural, wild, crazy system that propagates itself all by itself? So species selection is another tool that we can use. Doesn't mean we can't use or won't use species that aren't necessarily native to our site. It's just that we have the best success if we're going to use plant communities that are already adapted to our area. Some plants aren't adapted. Some individuals within that species, like say walnut, for example, some individuals aren't. Well, now we have genetics that we can play with. We can engage in mass selection breeding and remove the ones that don't meet our selection criteria. All of these are our control knobs on our regenerative agricultural system. This is a regenerative agricultural system, It's been producing yields, food, fuel, medicines, fiber, sugar for 22 years, and it's been giving those yields by me harvesting it. And if you look on the left, that's a radically different system than the one on the right. This has certain benefits to it on the left, that has certain benefits on the right. You choose which one you want. These are the different control knobs that we have to guide our system through time. And plants in a population through time, they maintain their populations by regeneration. The individual species regenerate, the whole family of species regenerate. They reproduce, they disperse their young, the seeds or cuttings or vegetative parts or root runners will germinate and become established. We go to the site establishment phase. And then regeneration includes both sexual and asexual reproduction. And remember, by definition, if a plant and animal community cannot reproduce itself and persist in the environment, by definition, it is not regenerative. If a plant and animal community cannot reproduce itself and persist in the environment, it is not regenerative. You got that? This is regenerative agriculture. Why is that? Well, because all of these plants here have been producing yields in food, fuels, medicines, and fibers at least for 1,200 years. It's known and measured and recorded historically for 1,200 years. These chestnuts and hazels and figs and olives and grapes and walnuts and basswood producing flowers for honey, and they reproduce over and over and over and over and over again. They've been interacting with humans for much of that 1,200 years, but we know for at least the last 80 years they've had no human interaction with it, and they're still propagating and actually spreading some of these lower slopes on the rock down here. That's all seeds falling downhill and somehow finding purchase in a crack and managing to grow. That is regenerative agriculture. And regenerative agriculture, agriculture that can reproduce itself with natural processes, is permanent agriculture. Now, on my wall back home, I've got this little diploma up there that says a Diploma of Permaculture Design. And it's signed by this guy called Bill Mollison. And he actually invented the word, and when he trained me, when I worked with him, he preached over and over again that we're talking about creating permanent agriculture, an agriculture that's always there. We don't have to plow it up and replant it every year. We don't have to help it reproduce, although it may do better if we do, but we don't have to. It's going to reproduce all by itself. And of course, later the term's morphed into permanent culture. Well, don't you think a permanent culture could be derived around a permanent agriculture? I think so. I do think so. Now, this is the Wikipedia definition of regenerative agriculture. Now, get this. They say that regenerative agriculture is a subsector practice of organic farming designed to build soil health, to regenerate unhealthy soil. Practices associated with regenerative agriculture are those identified with other approaches to organic farming, including maintaining a high percentage of organic matter in soil, minimum tillage, biodiversity, composting, mulching, crop rotation, cover crops, and green manure. You know, I'm not really interested in going head-to-head with the entire marketing prowess of the whole regenerative agriculture movement, but by definition, this stuff right here is nice. Maybe this is a practice or a couple of practices. That is not by itself regenerative according to biological and ecological definition. And if we're going to have any kind of agriculture, agriculture depends on plant. Plants obey ecological principles. And if you aren't reproducing yourself, that's not sustainable. That's not regenerative. Just isn't. If you go ahead and you do a little Google search for regenerative grain production images, this is one of the first images that comes up, because they're using cover crops and they're using, maybe some compost and compost teas, and they're trying to build organic matter in their soil. And what are they missing on the regenerative front? They're missing the fact that they have to replant the whole thing. They have to prepare the site, and the system has no inner dynamic of its own. They're driving everything on that site. What is regenerative in this photograph? That's what I loved about this picture. If you look at this, that's the regenerative agriculture right there. There is agriculture happening right under their nose. It's in their way of putting seeds out in their fields. Possibly that's an oak tree on the left and a cherry tree on the right. Maybe there's hazelnut bushes underneath, elderberries, blueberries, grapes, goose, but who knows what's growing in there. That's regenerative agriculture, not that. Okay, agriculture, food. We got to have some kind of food. I know I've mentioned this before. Here's some reality checks. You know, this was I forgot the guy's name. As soon as his presentation is archived, I'll send you to it. The doom and gloom professor at Princeton. Of course, he brought it up. The world food production must double by 2050. That's only 30 years from now, people. 30 years from now. I've been on my farm for 20 years, okay? And it's gone from cornfields to a young forest. We have to start yesterday, if not 50 years ago, to do this. We have to double world food supply just to meet demand. Demand is not that pretty either, when the majority of the human race goes to bed hungry every single night. Look how fast the population is growing. Even if our population growth rate drops down to 0.1%, which means 1 person in 10 gets to have kids. It's ridiculous. Even if we do that, the world population by 2050 is going to be almost 10 billion. 10 billion people, an additional 3 billion people on this planet we have to feed by 2050. And 2050 is right around the corner. And what's also fascinating about this, if you look at it, the growth of people in wealthy countries versus poor countries, the majority of people being born into this world over the next 30 years are going to be lower income, like the lower 80%, 90% income levels. So we're going to have how many more? Almost twice as many more people on this planet, and most of them are going to be even worse off than we are. Just a news clip from The Guardian. The 8 richest people in the world have the same amount of financial wealth as the poorest 50%. Half the human race, you add up all of their material wealth, don't even have as much as 8 people, 8 individual people. This is a tremendous potential, because what that tells us is these 8 people right here have an amazing amount of financial leverage and power to make huge rocking change, and somebody has to help them to help us make the change. And you know what, though? We can't afford to wait for them to get online. We have to do this right now. We don't have any time to wait. 30 more years. That's how you can access that particular link if you want to. And since I'm not paying to the questions rack, if there are important questions that come up, feel free to interrupt me. Now, one of the things about all these new people eating additional food, what is interesting, I didn't find a good graph for it, is actually income levels actually are rising across the globe worldwide, which means people are becoming a lot more affluent in the countries that have been less affluent in the past, which means they eat more. But what's most fascinating about it is what they eat more of the most is milk. If you look at this triangular line here, these are the projections of milk projected to go way the heck up here. Meat, of course, is way on the rise, and yet the growth and the total growth in demand for grains really hasn't increased all that much for people consuming. And this is the telling tale right here. The meat consumption per capita is going through the roof, and over here it's even higher. Now, why is that a problem? Why is that a problem? Greenhouse gases, global warming potential, how you actually produce that beef, how you actually produce that chicken, the pork, the milk, beef right there, the big criminal. Feedlot, grain-fed beef is the biggest greenhouse criminal in agriculture. Mealworms, let's just feed the grain to the mealworms in the first place, right? And to eat the worms, we get a far better carbon footprint. Energy use, ridiculous energy use, keeping all these animals confined, keeping them alive, antibiotics, pollution in the water, and the land use that's required to grow beef. Because remember, why is grain-fed beef so ecologically bad? In part because it takes 10 pounds of grains and legumes to make 1 pound of beef. We actually have 900% more digestible things that people could eat if we didn't feed it to the beef. So when it comes to standing side by side with the vegetarians and vegans, I'm on their side when they say human beings need to eat less beef. But I put a comma that eats grains and legumes. If the beef is used as a management tool in an ecosystem, I don't think there's too much of a problem with eating some beef in your diet. And part of what I talked about at the Princeton conference was an animal dentition. Showed like a wolf and a tiger and an elephant and a cow. And if you look at human beings, we have molars. 16 out of our 32 teeth are molars. So that means probably half of our food should be coarse vegetation. We should be eating lots of leaves. Then we have 12 incisors. So we can be eating fruit. And then we only have four canines for tearing meat off of bones and stuff, so maybe we should only eat about 10 to 12% meat. We also don't have a crop and a gizzard, which are required for grinding annual grains and legumes, to eat grains and legumes. We have a very small pancreas, which produces our insulin to help digest our carbohydrates, and a big, huge liver with all these different enzymes for proteins and fats and whatnot. Where human beings are not designed to eat grains and legumes or beef as the main food. So here's the big challenge. We have more people requiring more food. The biggest loss of agricultural land is not to erosion or to depletion, it's to urbanization. Is that the cities and the suburbs are sprawling over so much of the agricultural land that we're having less and less land available. So how do we produce 50% more food on a declining amount of land? And of course, remember, we've got water. We need water for this agriculture, both for the growing of the plants and for the processing of the plants, etc. And so where I start to take issue with a lot of different officialdoms, from the UN all the way to Princeton to this particular slide right here, that the only solution is to increase agricultural productivity. They're so short-sighted, and that all that they're looking at is this very limited potential to increase arable land. Arable land, you know what? Who gives a rip about arable land? Plant communities grow everywhere on planet Earth where there's a planet. And those plant communities have been feeding humans for time immemorial. Trees will grow right out of the rocks. You saw the pictures in Italy there. We don't need to limit ourselves to arable land. I also don't think that we should go into quote-unquote wilderness land or non-degraded land to do our types of systems. We should go into the most abused, abandoned, beat-up, crappy, lousy land possible. So, of course, we got this whole CO2 thing, whether you think that we caused it, human beings, at all, or are an influence or a factor, it makes no difference, whatever. It is measurable and observable that carbon dioxide levels are increasing in the atmosphere. That's undeniable. You just got to keep measuring it. What's interesting, people don't realize that CO2 increases in the atmosphere don't always help plants. Vines seem to be the winners in this, that vines are really, really taken off as CO2 levels increase. Look at this graph down below here. What's interesting about this, if nitrogen and water are not constraints, has all the nitrogen fertilizer it possibly needs and all the water it possibly needs, as temperatures get warmer, yields drop off. So the last year was the warmest year on record globally. What does that mean to crop yields? So we've got degrading and declining amounts of arable land. We have yields are stagnant. I don't know if I show that somewhere. We have CO2 levels rising. Crops are not yielding as high because of heat stress and whatnot. Water's becoming a shortage. Grain yields have leveled off and are stable. Look here again. That is not double the world food supply by 2050. These trends continue. We are not on an increasing trend. There's deep doo-doo here. And what's fascinating as well is increased levels of CO2 in the atmosphere actually somehow cause our grains and legumes to be less nutritious. Not that they were very nutritious in the first place. but these annual grains and legumes have even fewer nutrients in them than ever before. So the food is now less nutritious. How do you like that for a word? Nutritious. Lower yields, less nutritious, water shortage, temperature stress, shortage of land, increasing population, fuel costs going through the roof. This is the influence of water in Iran, just like this one right here, because what I wanted to show is this kind of cross. We have certain demand curves going one way and then water going down. There's a crunch coming. And last Friday, the professor showed that basically the big crunch is by 2050. If we don't get our act together yesterday, 2050 is basically, doomsday for the human race. We'll see. It's possible that I could still be alive by then. Water, total water withdrawal. Agriculture is a biggie. This one right here, Asian, huge consumer of water, is mostly for rice agriculture. Now, rice doesn't necessarily have to be a consumer of water the same way that irrigated alfalfa in California is. So this right here, I think, is a lot more unsustainable than this, because a lot of paddy rice agriculture, that's a fairly sustainable way to raise. Oops, I just pushed a button. Hope I didn't do anything wrong. Everybody still got me? Okay.
You're still good, Mark. You're good.
Yep. What's fascinating about rice is it's living in an aquatic ecosystem. It has an ecosystem already, and if you've got things like some fish in there, some mussels in there, some snails in there, and then you have some trees growing around the edges of it, and now you've got your semi-aquatic wetland, that actually is a fairly sustainable ecosystem. Of course, there's a lot of issues with methane from anaerobic digestion of the funk at the bottom of these paddies, but that is a far more sustainable water use than a lot of our American water use is. And the thing is, a large percentage of the world's population doesn't even have access to clean water for drinking. Like Liz, 70% of sub-Saharan Africa does not have clean drinking water. But of course, what I like about this, 100% of North America does, though. Can you say Flint, Michigan? How many of you people living in a municipality have done a water test every single year just to see if they're telling the truth that that's safe drinking water? So water is a severe problem. What's interesting about this big nexus that's happening, deforestation is still ongoing. Loss of agricultural land, need to double the agricultural output, human population going through the roof, water shortages. We have, in order to solve any one of those, we got to solve them all. This is no longer. Yes.
I don't often interrupt. I don't think I've done this forever, but I want to point this out and our audience. How many of you have wells? Throw in ones if you guys get your water from a well. A well that's on your farm or wherever it's not from a municipal source. A bunch of ones. How much do you think you're being protected for the quality of your water? Not at all. There's not a single regulation in the United States that requires a private well owner to do any kind of analysis of what's in their water.
And how about and how can you even protect your water if somebody puts in a CAFO not even anywhere near you, but it's in a recharge zone 300 miles from you, and all the waste goes down into your aquifer, comes down into your well? You have no recourse over that as well. So there's a lot of big doo-doo coming on, and the motivation to get off your butts and do something is very, very, very real. And one of the reasons why we call ourselves the Ecology Action Team, it's the big A. If you aren't doing something about absolutely every single one of these categories, no matter how small your step is, we have to make as many steps within our own little lives as we possibly can with the resources that we have beginning yesterday. Land conversion is the big thing. Right now there's so many of these primary forests that are being cut down and plowed up still around the world. And actually, believe it or not, I'm going to address this on Friday. In Canada, the largest deforesting nation in the world happens to be the great country of Canada. They are deforesting more acres as a percentage of the land mass, and actually more total acres than any other country in the world, period. The forestry, most of the forestry in Canada is removal of larger, older trees on a pure volume matter. So agriculture is the largest single cause of deforestation by cutting it all down and turning it into some sort of agricultural production. Most of it is small scale in poorer cultures, but large scale livestock ranching and plantation agriculture, like the wiping out of Borneo to plant oil palm and burning peat, tropical peat lands to plant plantations. And soy is expected to rise by 300 million tons by 2020. That's 3 years from now. It's ridiculous. On and on and on. Commercial timber used for paper production. I don't actually have a problem with commercial paper production as long as we're growing that paper in restoration agriculture systems. Now, restoration agriculture is reverse land conversion. We're going to go to degraded land and we're going to convert it back to an ecological system. We're going to weight the ecological system heavy on the food production, the medicine production. As a byproduct, we're going to get all the benefits of carbon sequestration. We're going to do the water management ahead of time. We're also going to get more hydration in the atmosphere, more hydrological cycling. We'll have wider diversity of foods and more highly nutritious foods, fruits and nuts and berries, in addition to animals that are now on the land. They're doing what animals are supposed to do, pooping and peeing, for example, and eating green vegetation. They're doing, instead of having to buy chemical fertilizer from all that whole chemical industry that does that, the animals are supplying the fertilizer. You don't have to eat them to benefit from animals living in a system. We're going to reverse land conversion. We're going to go into places that no corn and beans farmer would ever dream of farming in because they can't, because they got wimps for plants, wimps for crops, and they're hyper dependent on chemical inputs and mechanical inputs to have their systems run. When we design our systems after natural ecosystems, nature will operate them for us. Back to that mountainside in Italy, nobody has done anything to those mountainsides for over 60 years, and they're growing just fine, thank you very much, providing tons and tons of food, not for humans, but for all the animals that are very happy to eat that. So from the Union of Concerned Scientists, they've collected data from a lot of satellite data mostly. There's over 100 million square miles of land that was once upon a time high forest within 5 degrees of the equator that had been clear-cut, liquidated, and then burned or bulldozed or whatever, and grown annual crops grown in that land, and then after a period of time abandoned. 100 million square miles. Annual agriculture is not even thinking about those 100 million square miles because they don't have any clue as to how to deal with 100 million square miles of land that's just totally useless, degraded wasteland. Well, we do because we've been studying nature, and nature is it has systems for colonizing bare pieces of earth. And if human beings go away, for example, that 100 million square miles of abandoned land will revegetate. It will. Whoops, what happened? No. So, here we go. Let's do this on the abandoned land in the tropics. What if we used oil palm, which is considered to be a criminal? It's one of the largest causes of tropical deforestation. Is you go ahead, you liquidate an area, you log it all off, and then you convert it to an oil palm plantation. And that's measurable, observable. What if we actually went to this degraded land and used oil palm as 20% of a system? 20% of a system that looks something like this picture right here. And we use that as the economic driver that we can now press the oil, use it for fuel for our engines. We can use it in cooking. We can use it to make industrial products to feed to the industrialized people in cities and stuff like that. And we have plenty of other things in the system feeding us, producing medicines and so on. In Detroit alone, there's 40 square miles of abandoned land in Detroit. What about the other cities? Wayne might have a clue on some of those cities because he's worked so much in the brownfield area. This is a huge opportunity, and fortunately, more and more people are taking advantage of that opportunity. This is the kind of stuff that can be happening on all of that abandoned land. You don't have to own land to do this. And especially if you're using plants and plant communities that are natural, adapted plant communities, you go ahead and you put seed everywhere. You wouldn't believe the amount of seed that I've planted in cities throughout the United States of America. I won't tell why or where. I just carry my snack food along, and every once in a while I'll drop some of my snack food in a strategic location, and it's growing in places. I even go back to visit places where I've dropped my lunch before. All right, now we're going to do something that kind of, it has to do with regeneration, because we're going to show a picture of a system that is a regenerative system. By regenerative system, it's one that can actually reproduce itself and propagate itself through time. This is also a little bit of a parallel with our homework assignment with what we're working on, is that here's a couple, Johan and Lindsay, and their project is Fields Without Fences. If you go ahead and check out their website, you can see some of the stuff on there. Primarily, they're doing a bunch of medicinal herbs and juices and tinctures and extract. Lindsay is somewhat of the medicinal herb lady genius thing, and she's fast talking, super intelligent, hardworking. And Johan is also extremely hardworking, but he can't get a word in edgewise. They're a great couple. I was just there this past weekend working with them, and Johan has been working with Red, doing a couple different designs and installs. So where they got started is there's an ecological system called shrub swamps, sometimes called scrub swamps, buttonbush swamps. It's called buttonbush swamps because there's so much buttonbush that grows in there. It's one of the more common shrubs in it. It's kind of freshwater wetland. It's a little bit too wet to be a true swamp or a swamp forest, but it's too dry to be a marsh. And they're often considered a transitional form, a mid-successional between like a wet meadow or a fen that's more grassy-ish, then all of a sudden starts to get colonized by these shrubs, and eventually it can go through succession and turn into a hardwood swamp. A place where I grew up in north central Massachusetts probably could qualify as a hardwood swamp, but it wasn't one pre-European. Like some classifications, shrub swamps, about 50% shrub cover, less than 20% trees. And the other ones kind of say that it has large shrubs and small trees. Everything's less than 35 feet in height. If you've ever seen, I know I just was driving from Washington, D.C. all the way up to mid-state New York, all over the place on the side of the road. There's like these little flat lowlands, and it's not really a field, but it's not really a swamp, and it's not really a forest, and the plants aren't really doing all that well. It's just kind of surviving and getting by. Now, what's interesting about this is how shrub swamps are created. It often follows a catastrophic event in a forested swamp. There's flood, there's some kind of cutting, a fire, a windstorm. And another route is by drained meadows and fens that eventually progress back up to shrub swamps as the drainage gives up. Now, if you think about how many acres in the USA have tile drainage, especially in the upper Midwest, which is our corn and soybeans belt, that tile drainage is from the day you put it in the ground is beginning to fail and fall apart. It's a material thing, and it's going to fall apart. Also, the agricultural practices of continued either tillage or continued use of herbicides, so there's no more roots going in, putting all that carbon into the soil. You end up with a slow collapse of the soil structure, and it can cause the system to go anaerobic on you. And here's just a picture of what a shrub swamp might look like. It's got a bunch of shrubby things all growing. If you were to walk through here, you'd probably go over your boots half the time. But it's not really a lake, not really anything else other than that. This is actually a intertidal zone, but I wanted to show you the appearance of it. A lot of places, there's a few webinars ago, I don't remember which one, it was the special edition on water, I think, this summer, August, where there was a flat piece of floodplain field, next to the Kickapoo River. Well, we had those 600-year flood events in 5 weeks, and it was submerged for a long period of time. The vegetation died. It became anaerobic. It was supposed to be aerobic, but because it was underwater, conditions were anaerobic, the grass died. Well, when it died, the roots start to decompose, and the whole area starts to sink as that carbon decomposes and is oxidized, and the soil collapses on itself. It catches more water, holds more water, and it continues the process. So agriculture itself actually can cause these conditions. This is the property that Lindsay and Johan got. I almost said Lindsay and Lohan, but it's in New Jersey. It's on a peninsula, kind of flattish up on top, and drops right down to the Delaware River. In colonial times, that high ground was prime agricultural land. It's about 400 feet drop, just about a mile and a half straight into this picture, about a mile and a half straight into that picture. That bluffs 400 feet straight down to the Delaware River. Nice, big, flat, rolling tops, big, beautiful forest. Of course, they cut all the forest down, logged it all off, plowed up the fields, and had a lot of mixed cropping going on in the area. But because of continued plow agriculture from the early 1700s all the way up until just 70, 80 years ago, all that the soil starts to erode, the pounding rain, organic matter oxidizes, you had soil collapse, soil collapse, soil collapse. This area was agriculturally abandoned because it had turned into a shrub swamp, and nothing would grow there. It was very acidic, even though there's a fair amount of limestone in the bedrock. So also, if you wanted to see an area where there was some soil collapse, anaerobic soil collapse, to go back to the webinars that had the big, tall redwood grove, and Spencer Smith, Ruthie King, and myself were walking, and there's these big puddles in the grassy field next to it, and yet the redwoods were on a tuffet of soil 2 feet higher than the field was. And so this had gone into anaerobic soil collapse. What are you going to do? You're going to do, permaculture and, do a whole bunch of pretty little guilds that you read about in a book, or you're going to do the smart thing, which is what Lindsay and Johan did, is they looked around to see what was growing in the ditches, what was actually surviving in this shrub swamp. Well, look at that. This is a list of shrub swamp species in North America. And just get your reference material, wherever you find your reference material, and start reading it. Look at this, silver maple, red maple. Can we do anything with these plants? How about red maple for sugar? How about American hornbeam? Because you grow up to 2 or 3 inches, then you cut it down and inoculate with shiitakes. How about persimmons? How about American holly for ornamental uses? Swamp white oak for nuts, more shiitake logs. Willow for baskets, for Lindsay making her medicinal herbs. What's interesting about this place, this 10-acre little farm, they're making their entire livelihood from this by planting a shrub swamp. And of course, service berries are in the mix. Can we continue the list? Of course, aronia, buttonbush, pepperbush, dogwoods, witch hazel, winterberry. They're planting their chokeberries. They're planting silky dogwood, red osier dogwood for ornaments, witch hazel for a lot of the different astringent skincare products. Winterberries, Virginia willows, bayberries. They had a whole bunch of bayberries that were just starting to kick in, and they were actually using the leaves, making an extract from the leaves I think they were using it in oils or ointments. They're starting to produce berries, and so then they can start making candles in addition to their medicinal herbs. Rhododendrons and azaleas for flowers, and the big one in their system is the American elderberry. Probably 2/3 of every single plant in there is American elderberry. They got blueberries, nannyberry, black haw. They also have planted pawpaw. They know it's not in its particular zone or its regular habitat, but they planted it anyway. It's a moisture-loving plant. Do you think that you can sell anything from the maple, hornbeam, persimmon, holly, oak, willow, serviceberry? This is an agricultural system that if you walk away from it, it's going to thrive. It's going to do just fine. And this is their place 6 years later. 6 years later, from that to that in 6 years. That's what we're talking about with restoration agriculture. It's ecosystem biomimicry, load it on the side of the food because we want to feed ourselves, and then secondarily on the side of whatever it is that you've got that's your marketable crop. These guys probably have the most amazing understory, developed understory that I've ever seen of anybody. They've got slightly raised beds. It's all ditched, goes to a series of ponds. The whole property has it's very shallow slope, but they move all the water in big sinuous turns across it, and then their plants are grown up on raised beds. And most of the raised beds are managed with hand weeding, but once you've got the whole site colonized, almost every inch of space is occupied by one of your plants that you've planted there. They have all kinds of herbs. You know, can I think of any offhand, aside from just about everything, any herb I've ever planted? I'm not a supersonic herb specialist. Really, really good ground cover on that. Of course, unfortunately, I was there in February, so it looked like this. That's Lindsay, and there's raspberries now picking their way through the elderberries. As you set up a system like this, you get to learn what does better than other things, and you manage with pruners and a mower and a chipper. They have a subsoiler that they use every couple of years in the alleys in between. They're on a 15-foot alley, I think, and a 10-foot bed is what they're doing, and tremendous amount of elderberry juice. So once again, the process. Imitate your natural system, doggone it. You don't have to, but if you do, basically nature is working on your side. It really is. It doesn't matter where you are in this map or other maps. The natural plant communities of your area work really, really well. They really do. Manage and obtain yields from your water. Another statistic that Wayne sometimes likes to spout out there, that every pond of like a half acre of size in the USA, if every one of those ponds was used to raise some kind of fish, would basically take care of the whole world protein needs and not have to do anything. You just throw some fish in there. What was the statistic, Wayne?
If we used all the ponds in the United States that are an acre in size or larger, we could produce all the protein yield needed for the world. That's correct.
And so, is that an opportunity or what? This is a huge opportunity. Huge opportunity. Now, instead of going out there and doing what all these workbooks tell you to, and like hand hoe and pick every single weed and stoop over and work, just strategically disturb the site the way it's accustomed to being disturbed. Imitate a fire disturbance. Imitate a wind throw disturbance. Imitate grazing. Easy to imitate grazing by using grazing. Then your disturbance is the only work that you do, and the system you're working with its natural reproduction strategies, its natural regeneration strategies, and away you go. Establish your closely mimicked plant community. After you've done an initial disturbance, for all practical purposes, you can kind of walk away. Episodically disturb it again, mimicking herbivory, wind, soil movement, fire, as appropriate to the species that you've selected. You've seen these pictures before. And we disturb it by harvesting yields: food, feed, fuel, medicine, building material, sign wood, seed, honey, pollen, sap, bark. Yesterday I was out doing a lot of cutting in a system that looked like this. It's in an area that's mostly walnut, white oak, and chestnut are my crop trees. There's some Korean pine in there as well. And I've been harvesting every single year from it. Next week I want to address that particular spot because I got some fresh pictures just to show you what it looks like at this particular phase and have a little analysis of what I've gotten out of it. It started as a hay field 22 years ago. We actually harvested hay off of it for 2 or 3 years before planting it and then treating it as a natural ecosystem. This kind of system is zombie-proof because zombies only recognize gardens. You go ahead and plant a garden and the zombies will come and eat your broccoli and then you're SOL. So out of luck. Now we disturb it in order to keep it in the most productive successional phase in order to meet our objectives. We'll harvest multiple yields in successional time through the years, as well as throughout the appropriate season of the year. That's one of the things that was really cool about Lindsay and Johann's place, is they have a number of different crops that they harvest in the same place throughout the whole year. And now your food and livelihood, as you're interacting with the system, you're interacting with a natural plant community, and then hopefully in an intelligent and informed way. You are an intelligent and informed disturbance. And when you look at New Forest Farm, the place that I took over, it was abandoned cropland. Nobody wanted it. We got it for pennies on the dollar. It was extremely eroded. It was wasteland. And it's been feeding us and really well, I might add, and paying its own way through 22 years of its existence. And we were harvesting the decay cycle as well as the growth cycle, the nutrient recycling. And I think that's a beautiful place to go for a walk. Although I'm looking forward to seeing the green and the sunshine and stuff like that, I'm not necessarily looking forward to 116 degrees with total humidity. That's kind of miserable. This is ecologically regenerative agriculture. If you're using black cherry, oh look, it is black cherry. Or a birch, oh, it is a birch, and you can tap it for sugar. Understory of hazelnut, oh, there is hazelnut in the understory. Or red oaks for acorns, oh, there are red oaks, and what if those were Korean pine? One small little substitution. It would look just like this. We can go into abandoned land anywhere where agriculture will not go because it cannot go, and we can do it with restoration agriculture. This is regenerative agriculture. And this is regenerative agriculture. Man, when you got food taken over, I mean, that's okay, isn't it? I think so. Never mind. This right here, this is a job for restoration agriculture. We can go in here, you can buy a clear cut, literally. I know, I've done it. This is how I cut my teeth. You buy a piece of crap land that nobody else wants, and you start replanting your system. You replant your system at a profit because you're running a tree and shrub nursery, and with your extra trees, you're planting them on your own site. You're managing that site with animals that are feeding you. You're harvesting sticks, poles, wood, for firewood, building materials. You're yielding throughout the season berries, fruit, then eventually nuts, and then eventually wood, mushrooms all through the system. This can be farmed in every step of succession, and it's up to us to figure out how to do that so that this can be the end result and can be 100% food. Nobody at the UN is thinking about this land as suitable for agriculture. I do, and we can do it at the same time of taking carbon out of the atmosphere, cleaning up those streams, soaking water into the landscape, restarting, kickstarting the hydrological cycle, cleaning the air, habitat. How about animals that used to live here that don't have a place to live anymore? My farm never used to have weasels living on it in the past 100 years, 150 years. 3 different species of weasels. We've got badgers. We have way too many deer. I found one of the antlers, shed antlers from one of the deer I showed pictures of this fall. It had 6 points on one antler, so it may have been 12-point plus deer that did that. We're creating an amazingly abundant habitat for all kinds of creatures here, and providing food for human race. This is how we'll get the bang for the buck. This is how we can double the world food supply in 50 years, and there's not a minute to lose. Not a minute to lose. And that's all I've got to say for tonight. Thank you very much.
Awesome.
So I'm just going to say two things. Syntropia, Ernst Getsch. He's doing it in the tropics.
Awesome. You saw that one.
Yeah.
Did you see? There's a really good one that somebody else put up here. Let's see. It was Lee. Respond, or read what Lee said. It'd be better if you just read it and then respond to it.
Oh, well, yeah. One of the things. Think about that liver of ours, right? That liver of ours basically is designed for dissolving, digesting proteins and fats. This brain up here basically runs on fat. And when you go, let's start by dropping the annual grains and legumes, and let's try this diet right here with these many vegetables, these many fruits, and then just this much meat. Unless you're having a lot of nuts in there that you're also grinding up with your teeth, you're not going to get enough fats. Fats are very essential. Actually, cholesterol is actually a nutrient. And so, yeah, Lee's thing is yeah, he's totally right on. If you want to look more into like a lot of diet, Weapon A Price Foundation is really good on that. What's really fascinating is I started eating a diet that I could grow, and what I found out is I really couldn't grow grains and legumes very well without a lot of slave labor, so I stopped doing that. And so I just naturally turned into eating, meat and plants, because it's easy to grow plants, and now I've got a lot more nuts in my diet. But this proportion right here, this half plants, maybe 30% fruit is 12%. I don't do the math for me, please. And then only 12% meat seems to be working pretty well for me. My doctor he's a paleo diet guy, and he's a physician, and so he has a lot of fun studying me. So yes, we can subsist a lot on fat. It's all about the fat, man. When it's flavor, if you have some good fat in your meal, you just don't really feel hungry for a lot of stuff. You're satisfied. But anyway.
So Jen asks a good one right at the end there, Mark. The last one.
Yes. Of course, when I attract so many deer to my farm, are my food harvested negatively affected? Absolutely. One of the things that we have to understand I used an example of in my book, like 12. This guy has 12 steers on 100 acres. It's a real rocky hillside, and he's grown 12 steers. It's contributing to the food supply, the world food supply. Yippee! It's hardly, it's a grassland. It's nice. It has more photosynthetic potential than that. It can produce way more. Out of my farm, I think there's only like 30 acres that could be considered flat enough to till. Still would be steep and be highly erodible land. You should have terraces. It's going to erode and all that kind of stuff. So there's only 30% of my farm that's actually considered arable for agriculture. So out of 100 acres, that means 70 acres is not agricultural land. Well, so what I'm doing is I'm taking non-agricultural land and I'm making it agriculturally productive, and I'm not expecting it to produce top yields. I'm not expecting to get 4,000 pounds of chestnuts per acre. If I get more chestnuts per acre dollars-wise than I spent putting them in the ground, that's called profitable, and I win. And so, for one, my systems aren't producing as much as a orchard would. I don't care, because it doesn't take me anywhere near the amount of labor and nowhere near the amount of input. And yes, the wildlife is going to be consuming some of my crop, and it negatively affects how much I could sell. So if someone were to come on and have a slightly different management approach, one of the management approaches would be to kill more deer. Or the other management approach, and I just had a conversation with my wife about this last night, is to eat the resource that the deer eat. And I know that on my farm, primarily, the deer are eating chestnuts. I'm producing tons of chestnuts out there that I'm not harvesting, and the deer are. And they're getting really big and really healthy and really delicious. And so, so two neighbors shot deer. I didn't shoot a deer this year. I didn't see any. One of the ways would be to go ahead and manage that resource base, either harvest it, sell it, or get the pigs in there to harvest it and sell the pigs, and then there's just less forage for the deer, and they won't starve, they'll just move somewhere else. But yes, when I have so many deer, it does negatively affect the yield.
Kate's got a great one for you related to New Zealand, Mark, right before, right after Jen's.
Why would it be difficult to mimic the natural plant communities in New Zealand? It's just that what's probably some of the issues with that is that they're not common to the current food supply by the European imports. And so either figure out how to get an animal to harvest some of the natives, or to figure out how to make new foods out of the natives, or derive things out of those natives in order to, to sell them. The medicinal herb thing on the small scale is one way to do it. Industrial ingredients on a larger scale, there is something in everything that you can figure out how to do. Crush it, distill it, pulverize it, chemically dissolve it, reconstitute it. That's what food science is all about. You eat a package of prepared food, hardly any of it was put together from the whole ingredient. They're made from derivative products. Look at what's in the extra crunchy Cheetos. Try to read the label and understand it. So then, if you're going to use introduced species, you can mimic the plant communities from where those species came from, and it'll just be it'll be like, gosh, Cajuns in New Zealand, a non-native introduced species that somehow seems to be working okay.
So Jian has had a comeback for you, and I was just writing, but I think I know how you'll answer it. See what he put there. He says, "Oh, then that means you can really only farm if you have a large farm." And I don't think that's what you're saying. So.
This was related to me losing yields to animals. Is that what it's related to?
Well, I think talking about having 70 acres of your 100 that you've turned into a productive, not necessarily completely optimal, but it wouldn't have been farmed at all, was my answer before. It wouldn't have been
farmed at all. They're producing zero human food. Right, zero human food. So I've taken a system that was producing zero human food, with precious little animal food because it was so eroded and degraded, hardly anything grew there. And through the process of natural succession, we've gotten it back so there's actually soil that's black there that didn't used to be there. The issue with scale has to do with how much do you need to eat. And you figure out how many calories, how much carbohydrates, proteins, and oils, vitamins, and minerals you need in order to stay alive for a year. And depending on your climate, you may need more or less land to provide yourself with that. So if you want to produce your own food, you have to seriously, produce your own food. You have to have enough land to actually do that. If you don't have that land and aren't interested in going about getting land that sizable, then do what you can with where you are and partner with people who are doing this kind of agriculture who have larger acres of land, because we need people who aren't larger landowners, because that's who our market is. That's who we'll be selling our products to. And then some of the things that you don't get at a smaller scale are some of these ecological relationships that come into play at the population level. If you look at this last slide, you can kind of see in this middle elevations here all the white pine that are sticking in there. Whatever pest and disease that goes through white pine, it may take all 10,000 of those individuals as a community to be host to the pest or the disease. The pest or disease has its own life cycle. The next things come in, has its own life cycle. It takes scale and time to achieve a certain balance between, pest and disease in plant and animal communities. And so if you have one clump of Korean pines, you put 3 or 4 in the same clump so they have to be able to pollinate one another. If you have just one clump of Korean pines in your suburban yard, you say, I'm not going to do anything for pest or disease control, I'm not going to do anything to protect it from the deer, well, they'll come in and you'll get a disease and it can kill your trees, or the whatever insects come in and you have a worm in every single pine nut, or the deer comes in and eats all the foliage off your trees. So what you have to do in order to get that system to survive is different at every different scale. That's part of what I'm talking about. There is no simple answer. But that's okay. It's not complicated. It's just complex.
Well, Mark, John Paul put in a pretty good comment you might look at there, just because you've stated it before, but that apple you're producing is a little different than the one that you get from the grocery store, too.
Radically different. And there's a book by Joe Robinson called Eating on the Wild Side. And I thought it was fascinating. I first met Joe when her book came out, and she looked at the nutrient levels in plants, and the more nutritious plants were with more antioxidants, different phytonutrients, and all that kind of stuff, the more nutritious they were, they happened to be more pest and disease resistant. And I thought that was fascinating because what I found in apples, and I think it was also in berries, I forget which ones it was, her list of the most nutritious apple varieties, out of, let's say, 10 of them, 5 of them were the ones that are surviving on my farm. I wasn't looking for the most nutritious plants. I was looking for the ones that were pest and disease free, and so if the pest and diseases bothered them, they died. But the ones that have a lot more of these really complex flavors, some more bitterness, some more tannins, the pests don't like them. They go to the sweet, sugary stuff. Well, those ones that have all those different complex phytonutrients in it, they're just more nutritious for you. And so therefore, it stands to reason that the plants are healthier, you're healthier. Wow. So people who eat apples that have to be sprayed constantly, because if they're not sprayed, they get consumed by pests and diseases. That means that you're going to need to be sprayed all the time too, because you're going to get consumed by pests and diseases. So that was Joe Robinson, Eating on the Wild Side. Thanks for bringing that up, John Paul. Good seeing you this last weekend.
You have a great question here that I actually already told her is probably way beyond what we can answer tonight, Mark. But let's see, it's from Tiffany, and it's just a little bit up here. If you don't see it, I'll read it to you. I got to find it here.
Oh, that's a novel she wrote. Yeah. How small farmers can prepare for an increase in food demand is by growing more and more delicious stuff, and to enter into the third dimension and start growing trees, shrubs, vines, bushes in ecological systems by decreasing your inputs, lowering your labor, and managing the system by harvesting it. And managing it in such a way that you keep it in maximum photosynthetic productivity. And I'll address that at some point in time with the architecture of a plant allows it to capture more or less light. And so by playing with plant shape and plant design, that's part of, like on the small scale farmer thing, well, that's part of where the power of the design side of permaculture really comes into play. Because on a smaller site, you will have the time to be there and to manipulate it. Johan and Lindsay, I've already encouraged them to put way more photos on their website, because just by looking at the patterns that farm has taken on over time, that's where the magic that we can learn all about. Because everything from what a ordinary gardener would have is all on the ground. Well, they've got all on the ground, this flat, low-growing stuff, this medium-growing stuff, these kind of spiky up like this. Those are just the plants, the little herbaceous plants. But then they've got small shrubs, medium shrubs, cane fruits, and then they've interplanted it with short-growing trees and tall-growing trees. And eventually it's going to be a really amazing three-dimensional system. And because it's so small, they can maintain it by hand and with hand pruners. And so they can really keep that architecture dialed in to optimize sunlight capture. There was actually a student at University of Urbana, Illinois Urbana, who worked, he was in the mathematics department, but he was part of the student organic farm and worked at the Woody Perennial Polyculture Research Site. And he made some kind of computer algorithm that would generate, took a flat surface, piece of paper, for example, and then using this particular formula, how do you get it to always maximize surface area exposed to the sun year by year by year by year based on the different plant characteristics. And it was really fascinating to watch this thing run, and the graphics were pretty fascinating. And one of my questions would be is, how would it be possible to maintain that that maximum surface area architecture. Would it be economically worthwhile? Would we lose yields? Would it all go to wood? You know, that sort of thing. But it's really pretty fascinating. So architecture, design, eat good food.
I'll just quickly on my soapbox for a second, because you brought it up tonight, which is about aquatics. I had a little story from the night before last. So again, some of you know, I've got a fairly productive aquatic system on my farm, and the neighbors that I have around know that. And every once in a while, I'll have somebody come and ask if they can go fishing, and I allow it most of the time. And I really like it when it's young kids. And so we have unusually warm temperatures right now. We usually don't have ice out yet, but we do have ice out right now, and it can be actually some exceptional fishing right after ice goes out, because the fish have been hungry and all winter, and they're not really getting anything from the surface. So anyway, this guy went down there, and I had a little bit of time, about an hour after he started, so I went down, and he hadn't caught anything. And he was fishing not really very smartly, and he wasn't trying to say that he was a great fisherman. Well, I just decided, you know, maybe I could just show him a little bit. I know these ponds pretty well. I've fished on them for 10 plus years. Well, in an hour, we caught 122 fish. And
Wow.
That would have been enough to feed our neighborhood for the evening, by the way. Well, this kid was just beaming. I mean, he said, and it was just some little simple things that I was doing a little bit differently than what he does, and I knew what to be doing. And the point isn't catching all these fish. The point is that I have a system that's productive, and it's like what you do, Mark. It's stunned. I mean, I put some pretty, strikingly terrific or total utter neglect into it, other than having fun with it. And that's what we all have to think about. How can you take your property, do something with it that is simulating and mimicking what would have happened without management, and have some fun with it, and then show that to your neighbors and share with your neighbors. And it doesn't have to be large.
And actually, that's what I've been doing for the past 30 years of my life, is just hanging out and having fun, making a really beautiful place like this picture on the screen right here. And what's fascinating about it is it's paid my way. This is how I've derived my livelihood for the past 30 years, and it's been a heck of a lot of fun. But this is kind of a lead up to, but guess what? I'm almost in my mid-50s now. What I'm doing with property design and other people's places is taking more and more of my time, educating others to do this faster. I can go hang out at my place and plant trees and cut trees and harvest chestnuts and live happily ever after. But I feel that my skill is better used as a leverage to help others to do the same thing, so we can massively propagate this around the world. We need it now. And so what's going on, you may have known, of course, that I severed my rectus femoris muscle last fall. It's not surgically reparable. It's healed, but I'm not the same, man. I've got only have half a left thigh, and it gets tired. And so I'm looking for preferably a couple to start learning how to take over management of New Forest Farm. The only necessary requirements would be to grow an acre of acorn squash and harvest the 2 acres of asparagus that's already there. Doing cattle and hogs is optional for that couple. Maybe that could be another couple. We're looking for some farm managers, and this is not a short-term summer gig for somebody to show up. We've always had summer folks all along the line. We're looking for somebody who's interested in hanging out here and living a good life. It's been a really, really good life. So if you guys are all interested, you know how to get in touch with us somehow. I guess that's an official offer.
Yeah, and that's the whole purpose of this community. The other guy, there's a bunch of you that have those kinds of interests and needs too, and we're going to start promoting that more. It looks like you don't have any other questions, Mark. Lots of really cool comments. Sam says, great motivational one tonight. More than ever, ready to get the F with a couple of letters and a K out of the Army and get my farm in 2 months. don't need to share. Don't need to share with everyone. Haha. Well, I just did, Sam. Sorry. I didn't see that. I didn't see that. And then Jen, who's been saying here, I am to start. If I am to start what you do, what would be the ideal size? Jen, and you, I know you're a guy that literally just started coming to these not too many weeks ago, and I know what Mark's answer is going to be. With whatever you have, your deck, your backyard, your whatever, and eventually you can move up to more. But I'm gonna play it for Mark and Mark can say it himself. But Jen,
I started the first piece of real estate I bought was a clear cut, but I was doing it way before then. I was doing it in my parents' backyard. I was doing it in my apartments where I was, not telling my landlords, and I was doing it in city parks. Then I had the great idea to start doing it as a landscaper, start selling my services as an edible landscape person. And I guaranteed that the plants would survive and look beautiful, and if they didn't, I'd replace them. And so it worked for me. I got paid to practice and learn. So you start with what you got and whatever you have. And I started with 100% debt financed, no cash involved up front, and I even paid the debt with more borrowing. But look, I've had a really good life. It's been good. Yeah. I owe way more now than I did when I started. But what I own is off the charts. And somebody also made a comment about my kids not wanting to take over the farm. They already own it. So if I die first, they have to figure out who takes care of it afterwards. And they don't have to take care of it. That's what's awesome. I even took a vacation one year. I got back and the farm was better. It's a perennial natural ecosystem. Do you get it yet? Look at this picture on this page right here. Nobody's doing anything nice to that landscape. And it's still persisting. It's still regenerative. All we have to do now is go in there and interact with it in a way that helps it to do so, and away we go. And you may own one little quarter-acre chunk here, or you may own a 5,000-acre chunk there. It doesn't matter. That's the same ecological system that you guys are interacting with a different part of it. Anyways, getting late.
Well, hey, everybody. Let's let Mark go for the night. You guys will get him every week. Robert, thank you. You made a great